So we're on chapter 4 review, problem number 11. And again, we're trying to identify the probability distribution and use that probability distribution to ask some probability questions and look for unusual events. Remember, unusual events have a probability that is less than 0.05. This says a glass manufacturer finds that 1 in every 1,000 glass items produced is warped. Find the probability that the first warped glass item is in the 12th item produced. The first warped item is the first item, second item, or third item produced. And none of the first 10 glass items produced are defective. And so what we want to kind of look at this is notice that we have a chance of success being 1 in every 1,000, and that we're looking for the first time of failures. And so this is the geometric probability. So let's look at our probability distribution. So our chance of success, or getting a warped piece of glass, is 1 in 1,000. That means our chance of not getting a warped piece of glass, or failure in terms of the probability distribution, is 1 minus that, or 999 in 1,000. Now, our distribution for geometric is P times Q to the x minus 1. And so the first question asks for the probability that the 12th item, or 1 to 1,000, times 999 over 1,000 to the 12 minus 1, or 11th power. And we plug all that in on the calculator. I have it up here somewhere. And I get 9.8905 times 10 to the negative 4th, or approximately 0.001 to the third decimal place. And so this is an extremely unusual event. Having the first warped item in the first 12 would be unusual. Now we want the probability that the first warped item is going to be the first, second, or third. So less than or equal to 3. And greater than 0, right? So our first warped item is between 1 and 3. So we're looking for the sum of the probability of 1, the probability of 2, and the probability of 3. So we're looking for 1 over 1,000 times 999 over 1,000 to the 0th power plus 1 over 1,000 times 999 over 1,000 to the x minus 1 first power plus 1 over 1,000 times 999 over 1,000 to the second power. Right? Those are our three possibilities. And we add those up. So what do we get? We get 0.001 for the first one. We get 9.99 times 10 to the negative 4th. And we get 9.98 times 10 to the negative 4th. If I sum them all together, I get 0.00299, or approximately 0.003. So this is also an unusual event, that we would have one of these first three being where we would have our problem. And so now the last part we want to do is that none of the first 10 are defective. Well, that's going to be the complement of the first 10 being defective. Complement of the first 10 being defective. So let me back here. So we want P being x greater than 10, which is equal to 1 minus P being within the first 10. So we sum everything with the powers increasing all the way up to 9. And we sum all of them together. So let's do this here. To the 0 plus 1, 999 to the 1000. And remember, this is 1 minus this. Right? We've got to get that 1 minus out there. I'll put my equal sign over here. 1. So this gets parentheses. And I do this for each value in my probability from 1 to 10. And so I'm going to use my dot dot dots. (999) to the 9th. And I plug all of that in my calculator with the 1 minus parenthesis and then these 10 sums here. And I get 0.990. So our geometric distribution can find when the first error would happen, or in this case, there's a 99% chance that the error isn't going to happen in the first 10 things.